Let's see how all three laws of motion work together in a common situation. I'm holding a ball in my hand. The ball is at rest, remaining at rest, so Newton's first law of motion tells me that the forces on it must be balanced. There is no net force acting on the ball. So what are the forces on the ball? Well, the earth is pulling down on the ball. That's gravity. The gravitational attraction of the earth on the ball is a force. And that force is equal to the weight of the ball. So the earth is pulling down on the ball with a force equal to the ball's weight. My hand is pushing up on the ball. Now, at this moment, since the ball is at rest, we know the force of my hand up on the ball has to be equal to the force of the earth down on the ball. Those two forces act on the ball, they're equal, and they cancel out to give us zero net force, no acceleration. The third law of motion tells us that those aren't the only two forces. If my hand is pushing up on the ball, then the ball is pushing down on my hand. That's a third law pair. If the earth is pulling down on the ball is actually pulling up on the earth. That doesn't seem like it makes sense to us. You mean the ball is pulling up on the earth? Yes. The same force that the earth is pulling down on the ball, maybe around 1 or 2 newtons, the ball is pulling up on the earth. The earth is so large, though, that little bitty force doesn't really affect the earth. So we actually have 4 forces involved right now. Hand pushes up on the ball pushes down on the hand, earth pulls down on the ball pulls up on the earth. Which two of those forces determine what happens to the ball? Ball on hand, hand on ball, earth on ball, ball on earth. Well, the two forces that determine what happens to the ball are the two forces on the ball. The hand pushes up on the ball, the earth pulls down on the ball. Are those two forces a third law pair? Hand on ball, ball on hand, or hand on ball, earth on ball. They're not a third law pair because we've listed 3 objects: the hand, the ball, and the earth. Third law pairs only list 2 objects, A on B, B on A. So hand on ball, ball on hand is a third law pair. They're always equal. So which force is bigger, hand on the ball or ball on the hand while I hold it? Neither, they're equal. What about when I throw it? Which force is bigger? Oh, to throw it, the hand had to push up more on the ball. No, hand on ball, ball on hand is a third law pair. They're always equal. So that's true if I'm holding it, if I'm throwing it, or if I'm dropping it. Hand on ball, ball on hand are always equal. The earth on the ball and the ball on the earth, that's a third law pair. They're always equal, whether I'm holding it, tossing it, or dropping it. The forces that don't have to be equal are the 2 forces that are on the ball. The hand pushing up on the ball and the earth pulling down on the ball don't have to be equal. Right now they're equal, and I know they're equal because the ball is not accelerated. But if I accelerate it upward, the upward force on the ball has to be greater than the downward force on the ball. So to throw the ball upward, my hand has to push up on the ball more than the earth is pulling down on the ball. So the earth is pulling down on the ball with a force equal to the ball's weight. Let's just say it's 2 newtons. So in order to throw the ball upward, I have to push up with more than 2 newtons of force. It's a tug of war between me and the earth. Whoever pulls hardest wins. I won. I won again. Every time I throw the ball upward, I'm putting more force up on the ball than the earth is putting down on the ball. But if I let the earth pull down more than I push up, then the ball accelerates downward. To have a downward acceleration means that there's more downward force than there is up force. So the force of the earth on the ball has to be greater than the force of my hand on the ball. So this is a common situation where all three of Newton's laws of motion come into play. And in fact, that's true anytime you have any force anywhere on any object. All three Newton's laws of motion apply to every situation that involves forces. Whether the forces are contact forces, like my hand on the ball, ball on the hand, or the force is non-contact, like gravity, still puts a force on the ball even though the earth is not touching the ball. Magnetic forces and electrical forces can also be non-contact forces. Newton's laws of motion apply to them also.